Welcome to Critical Thinking Deductive Arguments Rule 28, Deductive Arguments in Multiple Steps. So this video is based on a workbook for arguments, 3rd edition by David Morrow and Anthony Weston. Now we're going to look at what happens when you have a deductive argument that has more than one logical move, more than one step, logically speaking. So we're going to illustrate this with a sample problem. We're not going to learn any new logical rules in this video. We're going to use the ones that we learned before, but we're going to look at an argument that makes more than one logical move, so it uses more than one rule. It's possible to use the same rule more than once or different rules. And there's no limit to the size of a logical argument. They can go on forever, but it's most common to see arguments that have, around 2 to 5 inferences or something like that. So this sample problem is based on the trolley problem, which is a thought experiment in ethics, philosophical ethics, where you imagine that there's an out of control trolley or train on a track, and it's going to run over 5 innocent people on the track that it's on. Maybe it's not necessarily important how they got there. You could imagine that there was an accident, say, and there's a bunch of workers who are lying on the track. You are looking at this from the side, and you're next to a lever that if you pull the lever, you can divert the trolley. However, the track that you would divert it on has one innocent person. And this is a somewhat artificial scenario, right? We're assuming a bunch of things. We're assuming that there's not time to do anything else. You can't drag anyone off the track. They're too far away. We're assuming that the people are of equal moral value as far as you know. You don't have any reason to believe one's a terrible person, the others aren't. And the point of these, somewhat artificial assumptions is because it is a genuine moral issue. Is it ever okay to sacrifice one person to save others? And that happens in real life all the time. People have to make those kinds of decisions, like in warfare, triage in medical environments, etc. So this is an attempt to answer the trolley problem, which is just a thought experiment asking you what is the right action, using a particular moral perspective or ethical theory, specifically one derived from that of the 18th century German philosopher Immanuel Kant. So let's look at the argument and then start to analyze it. If you pull the lever and divert the trolley, then you kill the one to save the 5. If you kill the one to save the 5, then you treat the one as a mere means to save the 5. Thus, if you pull the lever and divert the trolley, then you treat the one as a mere means to save the 5. You should not treat people as mere means. Therefore, you should not pull the lever and divert the trolley. So Immanuel Kant, he famously argued for a moral principle called the categorical imperative. And he gave different formulations of this moral principle, but one of them says you should never treat people as mere means to some other end. And it was, even though he wrote this in the late 18th century, a couple hundred years before the trolley problem was developed, that was developed in the 20th century, his theory would give this answer to the trolley problem. So he was clear that you should never sacrifice one person for the sake of others, and so that's what he would say as an answer to the trolley problem. So let's start by trying to figure out what the main conclusion of the argument is. This is potentially tricky because we have two conclusion indicator words, thus and therefore. So you can see there, and we're going to have that type of scenario in arguments with multiple steps. Because they're going to have more than one inference, there can be more than one conclusion. So there's going to be at least two conclusions. Only one of them is the main conclusion at the end. The first one is called a sub-conclusion. It's a stepping stone to get to the main conclusion. So if you're ever confused about which is the main one, you can just try to ask yourself, what's the main point of the argument? You can also just sort of start identifying the logical operators or other parts of the structure of the argument first, and then come back to the issue of the conclusion. So that's what we're going to do. We're going to start with identifying the logical operator terms. So these are if or not. Also, the word and can be included, but the workbook for arguments doesn't have any logical rules involving and, so we can ignore that should it happen. If and then are paired together. So if you want, you can circle or highlight then when you see it accompanying the if, But in this case, I've only put the word if in red because there's only going to be one logical operator for if-then sentences. So the then is always paired with some if. And you can also see we have, in addition to the three ifs, two nots or negations in the last two propositions in the argument. So now that we've looked at some of the logical structure, let's try to find what the conclusions are, or the main conclusion is in the argument. Like I said, there were two conclusion indicator words, and if you want, you can just go ahead and put a box around those or highlight them some way to remind yourself to pay attention to those two propositions, because that's going to be where the logical moves happen. That's where a logical rule is applied to derive a new proposition. So next, we've identified the conclusions and the logical operators. Let's try to find the simple propositions, and then we will translate this into symbols and then figure out what logical rules are being used here. So the first simple proposition is you pull the lever and divert the trolley, which we can symbolize by the capital letter P. You'll notice it recurs 3 times total in the argument, and luckily the wording is basically the same, so it's easy to identify. Do remember that the wording of the simple propositions can sometimes change. You need to look for their meaning to be able to identify where one proposition reoccurs in the same argument. Now let's look for the next simple proposition. You kill the 1 to save the 5. That's a different statement with a different meaning, so it's going to be a different proposition. We can call that one K. And this proposition occurs twice in the argument, once in the first premise and then again in the second premise. The third simple proposition is you treat the 1 as a mere means to save the 5. And this we can symbolize with the capital letter M, and that occurs 3 times total in the argument. So it looks like we've identified all of the simple propositions and all of the operators. The only words that have not been marked are then, and remember those just go with the ifs. So the next step is to start putting these into symbolic form. Now, the workbook for arguments just has us use the normal natural language, English language words if and then or etc. for the operators. If you're using a symbolic logic, you want to use the horseshoe or some other operator that stands for the conditional proposition. So the first proposition is if you pull the lever and divert the trolley, then you kill the 1 to save the 5. If P then K, or P horseshoe K. Let's look at the next proposition. If you kill the 1 to save the 5, then you treat the 1 as a mere means to save the 5. So that's going to be if K then M, or K horseshoe M. The next proposition is if you pull the lever and divert the trolley, then you treat the 1 as a mere means to save the 5. So if P, then M. And that's going to be P horseshoe M. You'll notice we have the word thus here, which is a conclusion indicator. So it indicates there should be some logical move. This is using hypothetical syllogism from the first 2 lines of the argument. So we can cite this as 1, 2, HS for hypothetical syllogism. And you'll notice the argument's not over, so there's going to be at least one more logical move in the argument. The next line of the argument is going to be you should not treat people as mere means, which is not M. So you could symbolize that with the tilde sign to indicate the negation. And then the last step of the argument is therefore you should not pull the lever and divert the trolley, so that's therefore not P. And you can symbolize that more fully with tilde P. And if you look at how you derive tilde P, it's from lines 3 and 4 using the modus tollens rule. So in this case, the order of the argument is logical. It follows that of an actual proof by natural deduction. So the last step is going to be the main conclusion of the argument. Now, there could be cases conceivably where the main conclusion is put first or even in the middle, but it is more common in an argument with several steps to just end with the main conclusion. And that's what we see here. Now let's look at a second sample problem. This one is based on the problem of evil from philosophy of religion, which is the idea that if God is all good and all powerful, why is there any evil or suffering or even any type of imperfection at all in the world? So this is one argument based on that issue, problem of evil. Either God is able to prevent evil or he is not. If God is unable to prevent evil, then God is not all-powerful. On the other hand, if God is able to prevent evil, then God is not perfectly good because he chooses not to do so. So either God is not all-powerful or God is not all good. Let us accept that God is perfectly good. Then we must admit that God is not all-powerful. So the problem of evil can be thought of as putting a kind of dilemma for someone who believes in an all-powerful, all-good God. The idea is that the existence of an all-powerful, all-good God is inconsistent with the existence of evil, suffering, or imperfection in the world. So you have to give up any one of those things. Either God is not all good, or God is not all powerful, or least plausibly, there isn't really evil or suffering or imperfection in the world. So this argument is that God is not all powerful, but there are other ways of solving, so to speak, the problem of evil. It's just whatever you do, it conflicts either with common sense or with what theists traditionally want to believe about God. So the first step is to identify the logical operators in the argument. We put those in red. You'll notice we have an or in the first proposition and a not, a negation in the first proposition. We have an if in the second and two negations as well, unable and not. So the un is one of these negations that might be a little bit hidden. You need to be able to recognize words that have the idea or meaning of negation in them, even if they're not using the word no or not. They could be using some other negation, in this case, a prefix like un. The third proposition has if and not as operators. The fourth has not, or, and another not. And then the last proposition has not or negation in it. So now we've identified the conclusion indicators and bolded those. The word so can indicate a conclusion, just like thus or therefore. The last proposition is interesting because it has a somewhat unusual conclusion indicator phrase. Then we must admit that. So there is a lot of variety you could have with conclusion indicators. Ones that are more common would be it follows that, or it follows necessarily that, it must be true that. But this is just a kind of variation on that same theme. We must admit that. The next step is to start identifying the simple propositions. The first one is God is able to prevent evil, which we can symbolize with the capital letter A. You'll notice this simple proposition recurs 3 times in the argument. Now the second time might be a bit tricky. God is unable to prevent evil. It looks different, but remember the un is a negation. It's a logical operator. So that's just negating the simple proposition A. God is able to prevent evil. You're saying God is not able to prevent evil, or it's not true that God is able to prevent evil. Now let's look for the second simple proposition. The second simple proposition is God is all-powerful, which we can symbolize with the capital letter P. And you can see that also occurs 3 times in this argument. The third simple proposition is God is perfectly good, and we can symbolize that by the capital letter G. You'll notice there's a lot of negations in this argument, so you have to really be on the lookout for places where the simple propositions are negated, but you need to be able to extract the simple proposition from its negated form. You'll notice we have a parenthetical clause here because he chooses not to do so. So basically, you have a choice about whether to make this part of the argument or not. The problem is it is showing a kind of inference there because there's a premise indicator. However, in order to spell out this part of the argument, you would have to fill in missing premises to show the logical structure. So that's kind of like an optional thing, especially for the purpose of this class. Whether you would do something like that, you would have to be able to fill in the logical blanks. But in this case, we can just ignore the that clause because he chooses not to do so. You could look at it as a kind of an explanation for why this proposition is true. If God is able to prevent evil, then God is not perfectly good. The idea here is that God is able to prevent evil, but he doesn't. So it would follow from that that God is not perfectly good. To totally prove that, you'd have to break it up into even another logical move. So for now, let's just start with translating what we have. The first complete proposition is either God is able to prevent evil or he is not. So that's going to be A or not A. So it's one of those cases where he is not. That is a stand-in for the whole compound proposition. He is not able to prevent evil. God is not able to prevent evil. We have to realize from context what proposition is being negated there. And it's also the phrasing of that sentence allows us to figure out, okay, you're saying either this is true or it's not true. So we can symbolize that by A or not A. If you're using symbolic logic, then that would be A wedge tilde A if you're using the wedge to symbolize the or disjunction operator. So now let's look for the second premise or the second line of the argument. If God is unable to prevent evil, then God is not all-powerful. So that's going to be if not A, then not P. Or tilde A horseshoe tilde P. The third line of the argument is if God is able to prevent evil, then God is not perfectly good. So that's going to be if A, then not G. So on the other hand, that phrase isn't really doing any logical work. It's just indicating, for the sake of clarity, that we're looking at the other disjunction, the other disjunct rather. So the first line of the argument is the disjunction, either God is able to prevent evil or he is not. And the second line of the argument considers if the first disjunct, or sorry, the second disjunct, not A, is true, what would follow. The third line of the argument considers if the first disjunct, A, were true, then what would follow from that. So now let's look at the next line of the argument. So either God is not all powerful or God is not all good. So we have two negations there. It's going to be not P or not G, which you can symbolize as tilde P wedge tilde G. And so that is going to be the dilemma rule, which here I'm abbreviating with a D, based on lines 1 to 3 of the argument. And I didn't have quite enough room to put the justification to the right of line 4. I'm just going to put it below. So of course, this is not at the end of the argument, so we know we're going to have at least one more logical move before we get to the end. So let's see what the next line of the argument is. Let us accept that God is perfectly good. So we can symbolize that whole statement by the letter G. And there's one more line of the argument. Then we must admit that God is not all-powerful. So that's going to be not P or tilde P. And if you look at the last line, it follows from lines 4 and 5 using the disjunctive syllogism rule. In this case, we have to extrapolate because the rule is using a disjunct and a negation, using a disjunction as one premise and the negation of one of the disjuncts as the other. So we have, in this case though, our disjunction has a negation already on each of the disjuncts, not P or not G. So you have to realize intuitively that G is contradicting or negating the not G. Now if you're doing this in a more formal symbolic logic context, then you're going to have to usually use another rule, double negation, to add two negations to the G before you can see that it's negating the disjunct of not P or not G. So it would be like not G. But intuitively, the double negations cancel out. So because we never learned the double negation rule in a workbook for arguments, we can just put disjunctive syllogism to illustrate the basic idea of that argument on lines 4 and 5 leading to line 6. And so this is the main conclusion of the argument. You can see we use two rules, dilemma and disjunctive syllogism.